Hello, Shomu sir.
Hi, Hajal.
So, of course, geometry, but what shape are we discussing today? Triangle, circle?
Yeah, so we have a very interesting question based on triangle, I would say.
Okay.
It can be simplified very slightly using a concept of incircle. But even if you don't do that, it can be solved. But I'll touch on that as we go into it.
Nice.
So let's jump
Okay.
in. Yeah.
Yes, sir.
So we have P is an interior point of a right-angled isosceles triangle. So it's a right-angled and isosceles triangle, ABC with hypotenuse AB, meaning C should be the 90-degree out here. Now, if it says if the perpendicular distance of P from each of AB, BC, and CA is this much, then the areas in square centimeter of the triangle ABC. So we are looking for the area of the triangle ABC. Now, this particular information that is given, so this is the only information, right? This distance of the perpendicular distance of P from each of the sides. So it says P is at a constant perpendicular distance from each of the sides AB, BC, and CA, right?
Right.
First, let us draw the triangle out here. So I'm just drawing a big figure. Yeah, so hypotenuse is AB. So let's say this is A, B, and C. This is the shape. Now, this point P is at a constant perpendicular distance from each of the sides, right? So suppose this is the point. You drop a perpendicular from P on this, and a perpendicular on this, and a perpendicular on this. Now, each of these perpendiculars are of this length, right?
Right.
Now, we're supposed to figure out the area of ABC. So obviously, we need to figure out the sides of ABC, right? That should be pretty obvious to understand. Now, for the solution purpose, what I'm going to do is I'm not going to first write this number because this is a very, strange kind of value that is given, right? So I'm just going to indicate this by some X. So suppose this is X. We know the X. X is basically this 4 into root 2 minus 1. So this is X. But I'm just writing this as X for now, just for indication purpose. I don't want to make this too hodgepodge. Now, look at this figure out here. This is 90-degree out here. This is 90-degree out here. And this is a right angle triangle. So this is also 90-degree out here, right? So 390 degrees. So making this one as 90-degree as well.
Okay.
And
Right.
adjacent sides are X. So basically this is a square, right? So this much should also be X. And this part should also be X.
X. Right.
Now the thing is, this is also an isosceles triangle, right? Obviously the isosceles triangle, it being a right angle triangle, the two legs of the right angle triangle should be equal. So implying this part should be equal to this part.
Right.
Now suppose I consider this part to be A, this much to be A. So this must also be A, right?
Right.
Now this is the part, if you understand the concept of incircle, this becomes very easy to solve because see, from this point, the perpendicular distance to each of the sides is constant, right? So if I take a compass and put the point here and take the radius as X and I draw a circle, that circle should pass through each of these sides. Is it?
Right.
It's not a circle. I don't know what figure this is, but assume this to be a circle, but it will happen, right? A circle will pass through each of these. And what do we know about a circle? Tangents from a particular point to the circle are equal in length. So from this point A, this tangent and this tangent should be equal in length. So this should also be A. Similarly, from B, if this is A, then this should also be A. Right. Now, this is the part I was talking about. Even if you don't catch this, you can prove this in another way, just by congruency and stuff. Okay, this was 90-degree. So if I just connect these two, let's remove this A for now. So what do we have? So this particular figure, let me just name this for evaluation understanding purpose. So let's say M, N, and P. So if I consider this AMN triangle and APN triangle, Can you see these things? I mean, there are too many things written out here. This is M,
It's visible.
this is N, and this is P. Okay. So
Right.
AM and APN, if you consider these two triangles out here, so this is 90-degree out here, right? This thing is A, this thing is X, and this is a hypotenuse of this particular triangle, isn't it? Now,
Right.
this hypotenuse is same for this triangle also, and this is X, meaning this should also be A. So we can do this A in a different manner, and this is precisely why, I mean, in a circle, two tangents are equal in length. So, but the circle thing is a little faster, right? I mean, if you imagine it using a circle, then it becomes a little easy to understand. I mean, that rather for a little faster to understand. You don't have to think about congruency and stuff. So once you arrive at this point, so you have these two parts as A. Now look at the whole figure out here. So you have a plus X and you have a plus X, right? And this is a 45, 45, 90 triangle, right? Because this is a isosceles right angle triangle. So if you have a 45, 45, 90 triangle, the sides are in the ratio 1:1:√2.
Right.
If this is A plus X, one of the legs, √2 times of that would be the hypotenuse, right? And what is the hypotenuse? 2A.
Correct.
So just solve this. So you have A plus X, cancel the √2. You are left with one of the √2s here. So you get X is equal to A into √2 minus 1. I mean, this A goes this side. Take the A common. So you have something like this. But what is X? Remember, this is X, right? So you have 4 into √2 minus 1 as X. So this cancels off and you get A is equal to 4. So as soon as you get A is equal to 4, your thing is solved. I mean, you don't have to solve anything more. Or, I mean, you can just figure this part out, right? Just need the legs of this so to get the answer. So this is 4. And 4 into √2 minus 1 is basically 4 √2 minus 4, right? So
Right.
the entire thing out here would be this plus this, right? So the 4 and 4 goes off. So you have 4 √2 as one of the sides.
√2. Correct.
So the area will be half into 4 √2 into another 4 √2 here. So this √2 into √2 and 2 cancels off, and you have the area as 16. That is the answer.
Okay. Nice. This was an interesting one.
And nice question. Yeah. I mean, this particular idea, this particular shape, I mean, if you remember in our lessons, I used to discuss about incircle and circumcircle of a right angle triangle, right? I mean,
Right.
this is any kind of right angle triangle, not just isosceles one. So if you have an incircle, so you get this square thing out here, and from therein you get that idea, right? I mean, suppose the in radius is R and the three sides are A, B, C. So you get that relation A minus R plus B minus R is equal to C. So this relationship comes from this particular orientation itself. So if you are aware of that, then the incircle might actually hit you.
Right. Right.
So yeah, that's it from my end.
Thank you. Thank you so much, sir, for this wonderful question. Thanks everyone for joining in.
If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.